So remember with one variable inequalities, we always solved our inequalities and we graphed our answers on a number line so that we could see all the solutions. Well, here with the two variable inequalities, we still want to see all of the solutions, so we're still going to graph them. This is a review of lesson 6.5 in case you need it. Maybe you were absent or you just need a reminder. So when we look at y is greater than x minus 2, we want to graph basically the line or the linear equation that would be equivalent to this inequality, okay? So when we're graphing, we can kind of think of it as y equals x minus 2, just to get us started, okay? With y equals x minus 2, we would look for our slope and our y-intercept. Our y-intercept is minus 2, so on our graph, we would go down to -2 and plot our point. Then our slope is 1 because it's what's in front of x. Since there's nothing there, it's really a 1. And so we would move up 1 over 1 to the right, up 1 over 1 to the right, and we would keep going with this. Now, with the inequality though, with the equation, right, we would be graphing this line, and that would be our answer. It'd be all the ordered pairs on that line. Now go back to the inequality. We're not actually including the line, right? We're focusing on y is greater than this line. Since it's just greater than, it's not greater than or equal to, we're going to do a dotted line through these points. We're not including these ordered pairs as solutions because they would not work out to be greater than the y. The y would not work out to be greater than the x on the other side. When you graph, make sure you use your arrows and make sure you extend it all the way across your grid. It's a dotted line because it's less than, not less than or equal to. Then, to figure out which way you shade, you can plug in a point. Pick a point on either side of the line to substitute it into your inequality. If it works, then you shade on that side, and if it doesn't work, you shade on the other side. The easiest point that I always pick is 0, 0, as long as it's not on the line or questionably on the line. 0, 0 is far enough off that I can tell it either is a solution or isn't. So let me plug it in. If I put in 0 for y and 0 for x, I would get 0 is greater than -2. Is that true? Is 0 greater than -2? Yeah, of course that is. So that means my shading is going to be on that side where 0, 0 is. I would shade all the way over here. All of these ordered pairs are solutions to the inequality. So 0, 0 is a solution. 2, 10 is a solution. -8, 8 is a solution. All of those numbers in that region are a solution. If you try to point on the other side, just to double check, if we try, maybe we try 5, -3. Let's try that. So 5, -3. 5 is my x. -3 is my y. -3 is greater than 5 minus 2. -3 is greater than, well, 5 minus 2 is 3. Is -3 more than 3? Absolutely not. So if I had picked that point originally, I would know I'm not shading where 5, -3 is. My solution region is everything above this dotted line, not including these points. Okay, well, let's try another one. The second example, notice we have 2x plus 3y is less than or equal to 12. Now, again, when you're looking at this, to help you get started on graphing, you can think about it like an equation if it was an equal sign. What would you do to graph an equation? You would get it in slope-intercept form. So get the y isolated. The first thing I would do is subtract 2x from both sides, and I would have 3y is less than or equal to, I'm going to put the minus 2x first so that it's in slope-intercept form, and then I would have plus 12. Then I would divide by 3 and divide by 3 so that my y becomes isolated. I get y is less than or equal to, okay, remember that it's okay to have a fraction here. This is your slope. So it's just -2/3 x, and then don't forget to divide the 12 by 3, it's plus 4. If this was an equal sign instead of an inequality symbol, how would you graph it? Well, I would go to my y-intercept, which is plus 4, and I would plot that point. From there, I would move with my slope, which is over here. It's -2 and then 3. So I would go down to +3, down to +3, down to +3. Now there's the line. Am I including the ordered pairs on this line now? Yes, because it's less than or equal to it, it includes the line. So you're going to have a solid line here, a normal line, not a dotted line. All right, so I'll extend my line out. Extend it all the way across your grid, please. And then don't forget your arrows, because the line goes on forever. And now we just need to determine our shading. You can shade, again, by plugging in a point and seeing if it works. I like to plug in 0, 0 because it makes the math easiest. You can also I like to think about it as, okay, well, y is less than or equal to this, right? So since y is isolated, if I go and hold my pencil at the y value, where would y be less than 4? Y would be less than 4 this way. So I think I'm probably going to be shading all the way below it. Let's try plugging in 0, 0 and double check. If I would plug in 0, 0, and I would do it into your original equation, I would have 2 times 0 plus 3 times 0 is less than or equal to 12. That is going to just end up being 0. Is 0 less than or equal to 12? Yes, 0 is less than or equal to 12. So I'm shading on this side of the line, and all of these points are solutions. You could give me a couple examples of solutions. We could say 0, 0 is a solution, -5, -5 is a solution, -8, 2 is a solution, 3, -2 is a solution. All of those ordered pairs will work in this inequality. I hope that helped you to review 6-5.